Good day to all. Today we are going to see about that operational amplifier. What is that operational amplifier and what are the properties of that operational amplifier? We'll see here. For properties of that operational amplifier, see here open loop gain. It is ideally infinite and the practical value of this open loop gain is 20k to 200k. The high open loop gain is virtual short between plus and minus inputs. Here the input impedance ideally infinite. CMOS op amps are close to ideal. Then the output impedance is ideally zero, whereas here in that input impedance is infinite, output impedance is ideally zero, and the practical values are 2 to 100 ohms. Likewise, a zero output offset, that's ideally zero, and the practical value is less than 1 millivolt. Gain band between product GB equal to practical values in megahertz. The frequency where open loop gain drop to 1 volt by volt. Commercial op amps provide many different properties like no noise and low input current, low power, high bandwidth, uh, low and high supply voltage. And the special purpose of this app amp is we can use as a comparator as well as the amplifier, instrumentation amplifier. Likewise, we will use for this operational amplifier. See, already I said that we can use as a comparator also. Here we will see some basic op amp configuration. Here you can see this is the voltage comparator. We can compare the voltage in this voltage comparator, digitized input. Here in that the plus will give a voltage, input voltage, and the negative will become as a ground. Here we will get the voltage out. The formula for that V out, voltage out, output voltage for this voltage comparator, you can see here V out is equal to VCC sin V in. V input will given by the problem as well as VCC also given by the problem. So we will easily find out that output voltage is equal to VCC sin of V input voltage. Then the voltage follower. Here also same as the voltage comparator, but the thing is here the negative part is feedback to the output section, which is here it is V out is equal to V in. Output voltage is equal to input voltage in that voltage follower. That is the main concept here. Then inverting input and non-inverting input amplifier. See, in non-inverting amplifier, we will have a positive. In that positive, we will have an input voltage. In negative, we will have a ground with resistance in that negative, and again we will have one feedback resistor. Then we have a output voltage. Here the formula to find out the output voltage in non-inverting amplifier, V out is equal to 1 plus R2 by R1 into V in. V in is nothing but input voltage. Output voltage is equal to 1 plus R2 divided by R1 into input voltage. That is the formula for non-inverting amplifier. Then inverting amplifier. The main difference, we will not give the any ground to this inverting amplifier compared to non-inverting amplifiers. See here, the positive connection will have input voltage, negative connection ground with resistance. But whereas here it is in reverse. Input voltage we will give with the resistance value R1, and in positive we will connect to the ground. Then another resistance will have a feedback from positive to output voltage. Here the formula for output voltage is equal to negative of R2 divided by R1 into input voltage. This is the inverting amplifier. Then we will have more things we can do in that amplifier. For example, here it's summing amplifier, which means we can sum this amplifier. How it happens? See, V1 it is added with the resistance 1 and V2 is added with the resistance 2, Vn resistance with Rn, which is n number of voltage resistance we can sum here in this summing amplifier. It is same as what we have seen in the previous. See here, it is a inverting amplifier. So positive is connected to the ground and negative is connected with the resistance and one output resistance also there. The formula for this summing amplifier is equal to V out is equal to minus V1 divided by RF divided by R1 plus V2 RF divided by R2 plus dot dot dot, which means we can go up to n number of voltage up to Vn divided by RF divided by Rn. That is the formula for that summing amplifier. Then we will go for differential amplifier. Differential amplifier in the sense we will have a voltage with resistance and V2 with resistance, and these resistance are same, and here again one resistor connected with the series with the ground, which is involved in that positive, and negative will have a one resistor with the output voltage. So formula for this output voltage is equal to R2 divided by R1 into V2 minus V1. This is the formula for differential op amp. Then we'll go for that integrating op amp. See this integrating op amp, we will have an input voltage here with the resistance R. Here you can see in integrating amplifier, the feedback is connected with the capacitor, whereas before we will see the feedback only have with the resistors. Here it is capacitor and connected with the output voltage. The formula for this integrating amplifier output voltage is equal to minus 1 divided by JWCR into input voltage, which is equal to minus 1 by RC. We will take this capacitor and resistance value back outside. So 1 by RC sigma V input voltage into di by dt. Because this j omega part is imaginary part, so here the formula will have minus 1 by RC integral of V input voltage into dt. Then we will go for the differential amplifier. See here differential amplifier same as integrating amplifier. The main difference is resistors will go for feedback system, and then capacitance will have the place within the resistor. See here input voltage with the connection of a capacitor, and the resistor R will have a feedback with that output voltage. The positive terminal will have ground, and the negative terminal will have a capacitor with the connection of input voltage. Here the formula for this differentiating amplifier is equal to minus R divided by 1 by j omega c into input voltage. So what will happen? This j omega c term will go upside. So this j and omega is the imaginary part. So this equation will become like negative sign of RC into input voltage, we have a differentiation dV in by dt, that is called the differentiating amplifier. Thank you.